regular function is synchronous, meaning that you call 3 functions one after another. You first execute one, and the second one starts only once the first one finishes. Yeah, this is synchronicity. One works after another. If you want to introduce asynchronicity, so to make 2 things happen at the same time, you need to use async await. For that, you need to use a coroutine scope. So this is the most basic pattern for introducing asynchronicity. But of course, even in such a simple patterns, there are many edge cases and mistakes. Welcome to practical patterns for Kotlin Coroutines in Android. I need to warn you, this presentation is overloaded with knowledge, which is my fault. I am addicted for teaching. This is terminal. I am coping with my symptoms by providing workshops and writing books, including the most popular book about coroutines, called Kotlin Coroutines. The agenda for today is that I would like to present to you first the most basic use cases for Kotlin Coroutines on Android. Then I would like to move into a bit more advanced ones, and probably over there you will find more of everyday use cases for you. I don't know why, but I've noticed Android developers prefer the most advanced features, often forgetting about the simple ones. But we need to start from the simple ones because this is where people mostly make mistakes. So we will start with the most basic element of Kotlin Coroutines, which is making synchronous and asynchronous calls. So basically in Kotlin Coroutines, all the suspending functions are synchronous by their nature. They are just like regular functions. Regular function is synchronous, meaning that you call 3 functions one after another. You first execute one, and the second one starts only once the first one finishes. Yeah, this is synchronicity. One works after another. If you want to introduce asynchronicity, so to make 2 things happen at the same time, you need to use async await. For that, you need to use a coroutine scope. So this is the most basic pattern for introducing asynchronicity. But of course, even in such a simple patterns, there are many edge cases and mistakes. Starting from something that I see surprisingly often on Android projects, async and immediate await. That makes absolutely no sense. Awaits the completion of the async process. Async function starts the process. So making await immediately after async is like pointless. Yeah, we start something asynchronous and we immediately await for its completion. So this is just no. This is exactly the same as what you would have if you inlined the body of those functions. Not exactly, but in most cases that's the same result. And if you do want to have those calls asynchronous, you need to separately start async. Async is immediately starting the process, unless it's lazy, but nearly always it's not. You would need to make it explicit to make it lazy. Practically all async calls are immediately starting the process, and await is just a way to await its completion. So await suspends until there is a result from this process, and it either returns this result or throws it if the result is an exception. If you need to start an asynchronous call for every element of a list, it's the same pattern. You just use async in a map, then you await all the elements. However, this pattern, since it is quite repetitive, I often extract as a function, very simple function, map async. There are different variants. You can use a semaphore to limit concurrency, but essentially that's the most basic form. This form is much simpler. It's a suspending function that is first starting asynchronous process for each element, and then awaiting their completion using await all. Now, time for a pattern that is an incorrect pattern. This is one of the mistakes that you can find in Android projects. One of the first mistakes I am looking for when I'm making a review of some projects as a contractor, because that is confusing people quite often. People willing to start something asynchronous in the middle of a suspend function, they use launch or async. And if they do that before something suspending, that makes sense. But if they do that and there is nothing essential after this launch of async, that is literally pointless. Why? Because of structured concurrency. This launch is a children of a coroutine scope. And because of the rules of structured concurrency, parent needs to wait for its children. Coroutine scope is essentially a suspending function that starts a coroutine, but it's a synchronous coroutine. Yeah? It starts a coroutine, but it suspends the current one until its own is completed. And this coroutine cannot be completed before all its children are completed. And I hope you can see this code works effectively the same as if you had no launch whatsoever, which is, well, a good pattern. If you want to have a synchronous fetch user and then save user, that's the perfect pattern. Just make it explicit, because this launch is only confusing people. If you do want to start this save user asynchronously, then you need to be outside of this scope because of the rules of structured concurrency. If you start this save user on the same scope, the scope must await it. If you want to start it on a different scope, a scope where no one will await it, you must use a different scope, like an application scope, or if you inject a ViewModel scope or any other scope, but some different scope. But if you do that, remember, you are, I mean, on one hand, you are starting an asynchronous process, but you are also detaching from the current relationship of coroutines. So if update user is now cancelled, in the second case is now cancelled, save user isn't. Yeah? So you are starting a new process that is only related to the scope. So both patterns have their pros and cons. You just need to decide what do you want. You either make it synchronous and on the same scope, or if you want to make it truly asynchronous, and synchronous in relationship to update user, you must detach it, you must attach it to a different scope. That's a general rule, and that kind of starts the big discussion that I want to understand. You see, I started this section saying that the first code is synchronous and the second code is asynchronous, which is only partially true. I mean, in the second call, get profile and get friends are asynchronous in relationship to each other. Yeah? But the function produce user is synchronizing them. Yeah? So it is awaiting the completion of them both. If you truly wanted to start something asynchronous, you would need to have a scope instead of a suspend function. Yeah? Suspending functions by nature, by design, are awaiting the completion of the process inside of them, because suspend functions by contract are synchronous, are supposed to be synchronous. And so if you want to do something like truly asynchronous, you would need to design it completely differently. Yeah? Like this show user that is starting an asynchronous process, which is of course what we do on view models, what we do on launched effects. We start a completely independent asynchronous process. What scope should you use if you want to detach from the current scope? Of course, if you have some appropriate scope, ViewModel scope, lifecycle scope, or a scope from the composable, perfect. Use it. It will be cancelled appropriately. But if you want to start something that is like detached from that, what you shouldn't use is a global scope. Why? Global scope cannot be cancelled, cannot be overwritten for testing, cannot be configured. It is a poor choice. It's a lazy choice. A proper scope should be injected. Such a scope can be quite easily created in an application or in a DI. It is often just a coroutine scope with a supervisor job, sometimes with some dispatcher, and sometimes with some coroutine exception handler. But it must be injected either a scope or a dispatcher for testability. Okay, moving to the next section, cancellation. Cancellation is a section that we could spend whole day on. Okay, it's a very important section, especially on Android. And Android, everything is cancelable. When you start something on a ViewModel scope, it gets cancelled. When this ViewModel gets cancelled, destroyed. On lifecycle scope, when this lifecycle gets destroyed. The same in components. Components also destroy the coroutines they started if they get destroyed. So how does it work? Essentially, the idea is very simple. When you cancel the scope, this scope cancels all its children. Those children cancel all their children. They cancel all their children. All the coroutines get cancelled. But what happens to the body of those coroutines? They shouldn't get forgotten because, well, we we have some things that must be executed in case of cancellation. We should have some we should have some cleanups, closing connections. There are some things that just must be executed in case of cancellation. So how to have a cake and eat it too? How can we finish those coroutines as soon as possible while still executing all the cancellation, all the mechanisms that must happen on cancellation? The answer is exceptions. On every suspension point, on the first suspension point, there is an exception thrown. It's a special exception, cancellation exception, and it helps us complete the coroutine as soon as possible, as fast as possible, while still executing all the finally blocks. The same happens in suspending functions. Cancellation can also go, exceptions can also propagate from the bottom and go up. If you have an exception from for instance, on a request user, bam, this exception gets propagated up to the coroutine scope, breaks it, cancels all the other children. So this way we free the connection of the request user as soon as possible. We do not waste resources. We avoid a memory leak, what happens in most other libraries. And then this exception is thrown. The simple rule in here is that asynchronous coroutine builders, like async or launch, they are propagating exception via scope. Synchronous coroutine builders, like coroutine scope with context or run blocking, they are throwing this exception, so it can be caught. In this case, it can be caught, and the coroutine can continue propagation, which is consistent with the behavior of a suspend functions. Now, what are the edge cases here? The first edge case is what if you want to start multiple asynchronous processes with launch. Remember that if any of them has an exception, all the other get cancelled, an exception goes up. This is typically not what we want when we have independent processes. That's why for independent processes, we typically use supervisor scope. It ignores its children problems. So if you have an exception in a launch, it gets ignored. Okay, that's the behavior. That's typically what we want. And that's a typical solution for independent processes started on a suspending function. Another problem is that since cancellation happens on suspension, if you have a lot of operations without any suspension in between, it won't get cancelled until a suspending point. Yeah? In here, if you have a cancellation during the first CPU intensive operation or blocking operation, cancellation won't really happen until the whole coroutine body is finished. Yeah? It will all be executed. How can we give a space for cancellation? There are three main ways to do that. We can either use yield, which suspends and resumes, give a space for cancellation and redispatching. We can use ensure active, which is a lighter function that is just throwing an exception, cancellation exception, if the scope is cancelled, so it is giving a space for cancellation. Or we can use plain old is active, like in bad old Java. The next problem is what if you need to use some suspension in the middle of a cleanup. Yeah? As I told you, in a cancelled coroutine, you cannot suspend, because if a coroutine is cancelled, every suspension point, bam, cancellation exception. So if you use a suspending request in the middle of finally, it will also throw an exception, and it will never get executed. And that's actually very dangerous, because it's silent. You don't know that it has never been executed. So all the suspending operations inside finally blocks, all the things that should persist cancellation, should be wrapped with context and cancelable. That's a special block that is wrapping over things that should be should persist cancellation. And the last trap related to cancellation is catching cancellation exception. It can be either a generic catch exception or a little bit more specific, like runtime exception or cancellation. I mean, cancellation exception would be a bit stupid, but you can use also something specific. It is illegal state exception, if I remember right. So that is very dangerous for our coroutines mechanics to consume this cancellation exception and not rethrow it. And we are messing with the mechanism, and it can lead to some terrible mistakes that I show on my workshops and on the new edition of the book. And there are two ways how to deal with that. We can either catch it separately and just rethrow it, or another approach, we can ensure active at the end of the catch block. Both of those approaches have their pros and cons, and there are discussions on which to use. Some people argue for the second approach. We don't have time for such discussion, but both of them have their pros and cons. Now, the repository layer. We spend a lot of time in repositories on Android. We need to use a lot of libraries for communicating with our device, with network, and it's so good that nowadays we have support for coroutines in majority of those libraries, and we just should use it. If you have support for suspending functions on a flow, that's always the simplest answer. That's what you should use. So if you have a retrofit room, just use a suspend function. You don't need anything else. The rest of the slide in this section is directed for cases where you need to use a library that doesn't have such support. Okay. So what to do if you want to have a coroutine specific API and you don't have it? How can you make your own wrapper? And there are three typical situations how to deal with that, or three typical situations. The first situation is when you have a callback API that emits only one value. The typical pattern is that we use suspend cancelable coroutine, that will cancel our coroutine, but before canceling it, it will execute this block. In this block, we can start a callback function, and we can specify how our coroutine should be resumed. On success, resume a value. For instance, on exception, we can also resume with some result failure, or resume with exception, which means throwing an exception out of the suspension point. You should also remember about invoke on cancellation call cancel. If you have a callback API that provides more than one value, you should use a flow instead of a suspending function, and you should use a callback flow, a very simple API trace and blocking for sending elements, cancel if you want to cancel the coroutine, and with an exception flow, and on completed if you just want to complete it. Register, await close. Await close is necessary even if it is empty. If you need to use a blocking API is an API that blocks a thread. The most typical ones are those that are interoperating with operating system with Android, like operating on files. This is a blocking API because Android does that, and when you're waiting for the file content, it's blocking your thread. Or there are some libraries that are blocking, many libraries that are providing blocking APIs. You should never block on coroutines because that most typically means blocking either dispatcher's main, which is a terrible solution, which means making blocking your UI thread and preventing your application from running smoothly. You should never block dispatcher's default. The safest approach is to block dispatcher's I/O. That should be enough for Android. However, you should also know that if you have a suspending API in a properly implemented library, and well, that is certainly true for the majority of libraries we use, you don't need to switch your dispatcher into dispatcher I/O. Suspending API should never block thread. That's a contract of a suspending function. If a library is abusing that, that's an issue, and that's a big problem that should be very much criticized. Suspend function should never block a thread. Should be able to be run on any thread, and that's what all libraries that I know respect nowadays, okay? So if you use a retrofit, if you use room, you don't need to wrap it with dispatcher's I/O. You can just use the call plainly and simply. I know that people use dispatcher's I/O for safety because they do not trust libraries. They do not trust that this library is not blocking. And there is nowadays a really nice solution for that. There is a popular library called Blockhound. Essentially, you just add that dependency for this library, you install Blockhound integration. Don't do it on production, but you can do it on debug mode, you can do it on your tests, and this will hound and throw exception whenever you are blocking a thread from a dispatcher that shouldn't be blocked. Yeah? So such a call will cause an exception. Here is a link for Blockhound, and you also need to use Kotlin Coroutines debug integration, which is amazing. Works like charm, so easy to add it on a debug mode. And finally, the last section, I guess, for you Android developers, that is what will hit you most. So let's talk about flow. Again, starting from the most basic but highly repetitive pattern from a flow. What to do when you need to turn suspending function into flow. The most basic pattern is just use flow, call suspend function, make emit. In between, you can do much more than that. You can use multiple suspending functions and finally do emit. You can make some modifications, but that's the essential template. That's how you turn a suspending function into a flow. You can also make suspend function call and then use a flow in the following way. Use a flow. You make a suspending call, and then you create another flow based on the result of this result. And from the second flow, you need to emit to the first flow. You either use emit, collect emit, or let emit all. In theory, we shouldn't need this pattern too much because it's like very much mixing two words, like the suspending calls and flow calls. In practice, I see a need for that quite often, so I'm presenting to you first so that you know what to do if you need that. On the other hand, it's much simpler, of course, first or to list or something like that, suspending functions that are accumulating elements. Another pattern I wanted to present to you is a cache. This pattern has multiple phases. In this case, I just made a raw value that I store and I emit, but it can be a map of values, it can be a cache, it can be a real cache that you add from some third-party libraries. The point is that you have a flow, you use onStart to immediately emit the last known value from cache, yes? So this will be immediately emitted out of this flow when someone starts collecting on this flow. And also use onEach to update this value. As I said, if get curses were parameterized, last curses were probably some concurrent hash map, and you would update value from the concurrent hash map and get value out of the concurrent hash map, but it would be essentially the same pattern. And now a very important discussion that we need to make, a little bit controversial, but I think it certainly deserves some explanation here. Let's talk about the difference between SharedFlow and StateFlow and then when to use each of them. So SharedFlow and StateFlow are both hot flows. SharedFlow can be compared to a mailing list, where whenever you emit some value, whenever you send some value, emit some value, all the listeners receive it. By default, only active listeners receive it, but you can configure it, you can increase reply, and then the new receiver receives the certain number of past messages. Now, what is StateFlow? StateFlow is a shared flow. Essentially, StateFlow implements shared flow interface. Mutable StateFlow is a mutable shared flow, but it has 4 key characteristics. So first of all, it must have value. So we must specify this initial value for the StateFlow. Second of all, it is having reply 1. Always. You always receive the one last value. You cannot change that. Third of all, this is where we reach the area where people are not aware of that. StateFlow is distinct until changed. So if you again emit the same value that is already set, it will never be emitted. It will be ignored. Okay? And finally, that is the least known characteristic, StateFlow is conflated. Meaning that if you have a lot of updates and listeners are too slow to handle them, the intermediate updates might be lost. And all those characteristics make StateFlow absolutely perfect for keeping a state, yes? So if you have something like showed progress, something to show, something to display, any kind of a state in our ViewModel, it is absolutely perfect to represent it with a state flow. You want reply 1 to whenever you subscribe to receive the current value. You want distinct until changed to not, redraw something that is identical. And you want conflated because if your redraw is too slow, you don't want to display past values. You only want to display the most recent value. Everything is perfect for that. What StateFlow, though, is not that perfect, is to represent events. It is not for representing events. And so for representing events, SharedFlow should essentially be used. You shouldn't use like a mutable SharedFlow for a state, and you shouldn't use a StateFlow for events. Okay, I will get back to that in a moment. Now, let's start with some basic usages of SharedFlow and StateFlow. SharedFlow is, of course, used like an event bus on Android. So whoever subscribes receives updates. But it is also used as a very important optimization on our services, repositories. For instance, if you have some WebSocket that multiple parts of your application need to use at the same time, you can use a StateFlow to have only one connection. Yeah? If you use the regular flow, every flow would start a new connection. If you take this connection, use share in, and start it while subscribed, you can have multiple observers observing data from the same connection. Very important optimization in some kind of applications. Yeah, very powerful. On the other hand, StateFlow is, of course, the most basic way to represent things on ViewModels. We represent practically everything, or nearly everything, on ViewModels with a StateFlow, unless you use a state from Jetpack Compose, but that's another discussion. Traditionally, we use StateFlow for observing things on ViewModels. And StateFlow can also be stated in. That's also a common pattern. That's just a simplification. This pattern is a simplification of an init block that starts a coroutine and starts observing. Instead of all that, you can just use the flow, state in, initial value, scope, and this started. That's a bit of a magic value, but it's quite commonly used. This pattern can be made more complicated. You can use retry, you can use on start, you can use on completion. So there are many things that you can do in here. But essentially, that's just a simplification of a pattern that starts a coroutine on an init block. Now, the controversial discussion I need to start. I published an article recently about it after many discussions with many people. How should we represent events with ViewModels? ViewModels are not that typical use case because you should remember that when you have a ViewModel and down there there are views. Those views can sometimes, first of all, the views can get detached from the ViewModel. So if you like rotate an application, or in other cases, it's possible that the view will be detached and a new view will attach. There will be a space in between when no one is attached there, and so using SharedFlow, a raw SharedFlow, is a little bit dangerous, yeah, because you can lose some events. So what approaches do we have in here? I collected 4 most common approaches, but each of them has its own problems, okay? So let's start from the one that I see most often, which is just using a StateFlow with a value, like something like snack bar, or a dialog to show, or something like that, a throwable. You, in case of an error, you set value. In the fragment, you collect those values, show snack bar. Once you show it, you clear snack bar, and that's it. Yeah. So what are the problems of that? There are actually many problems of this approach. The 2 that are most the most important ones are that first you can lose some events. So if you have very quick events one after another, because of conflation, you can lose intermediate events. Or if you have 2 identical events, you will only handle one of them. Yeah? So the mechanics of a StateFlow will drop updates, which is not great. Also, it's possible, because of cancellation, to see the same, to have the same event handled twice. For a toast, snack bar, it's probably fine. That's probably what we want. But notice that you can show, it's possible that we show the snack bar, but before we clear the snack bar, there is cancellation happening. So we never cancel that, so we'll show it again. Okay? Another pattern is using SharedFlow. A row SharedFlow can be improved by this block subscription count first, it bigger than 0. That's a nice trick I found in some projects. This block is essentially awaiting until there is at least one subscriber, and this is actually a very cool approach. It is kind of fixing the problem of a shared flow, but not fixing entirely, because there is a small possibility that that element will be lost because of cancellation. If it got handled but never, if it got received but never handled, and this is where cancellation happens, it's possible it will never be really handled. Yeah. As far as I know, it shouldn't happen if you use this, if you emit this error in dispatcher's main immediate. And also, it's a very tiny space of that problem. So it's a very tiny possibility, but there is a possibility, and you need to be aware of. Another approach with exactly the same problem is using channel. Channel is slightly different. Channel if you use a channel, you can only have one receiver, because only one receiver will receive it. And then there is also a small possibility of losing event due to cancellation, because of the same problem. If we received it, but we got cancelled before we really showed it, or we did something with it, it might be lost. Okay? And the last approach, which is, from my experience, most often suggested by Googlers and other people very close to the design and architecture, is to turn our state, our events into a state, and turn it in the safe approach. So here we could just use a state flow and have a list of events to handle. So it's like a more complicated version of what we had before. It is eliminating the risks of missing events. So now we won't miss any events. All events will be lost. The only problem is that the same event can be handled twice because of cancellation. And the other problem is that it's the most complicated of the approaches. It's a repeatable pattern, so you can treat it, okay, it's just a repeatable pattern, I can repeat it, but it's just the most complicated out of all the approaches. So choose your poison. From my perspective, all those 3 patterns are perfectly fine. You can decide which one do you want to use. The last thing I want to present to you here, as I also see it quite often on Android projects. In Android, we often have some observable search. And when someone is typing, we want to provide some suggestions or display some elements. For that, we typically use first of all the buns to not to not start a new process every single click. So this eliminates the intermediate processes. Like every last click, there is like 300 milliseconds space between we will start fetch product search. And there is flat map latest. Flat map latest is like flat map is a flat map that is canceling the previous flow when the new one appears. Yeah? So it is most appropriate for this use case. And this pattern can also be used, can be implemented with Android-specific tools, with pagers, and with cache-in. This is, of course, having its advantages, but also its added complexity. So again, you choose what you prefer. And that was everything I have to you, and I had only 1 minute left. If you want to learn more, you can find it in my book, Kotlin Coroutines. On the workshop, there is an open edition in February, and that is everything from my site. Slides will be published on Twitter. Thank you for your attention.
Thank you, Marcin. Thank you so much. It was very insightful. I found out that I made so many things wrong in my developer's life that I will need to go back to those slides and see really into deep what's there. Do we have any question from the room?